Okay, so today we're going to be looking at the remainder theorem. Now, if we have a polynomial, okay, and here's my polynomial, p of x equals a0 plus a1x plus a2x squared plus all the way up to an x to the n. Now, we would say that polynomial has a degree of n, okay, so the degree of a polynomial is always the highest power that's in there. So quadratics have got a degree of 2, cubics 3, quartics 4 and so on. Now if we divide this polynomial by a divisor, x minus a, and we get a remainder, then that remainder is the value of this polynomial when a is substituted in for x. Okay, and that is always the case. That essentially is the remainder theorem. Okay, so we can write this as p of x, that's our polynomial, is x minus a, which is our divisor, times the quotient, the quotient of x, okay, so the quotient is what happens after you've divided something, plus a remainder. So here's a bit of a proof. For those of you who are looking at excellence, it may well come up in something like that. So here we are, we're given that this statement is true. I'm going to let x equal a. So obviously as soon as I put a into here, that's going to go to 0. Okay, so I get 0 times the quotient, which is here. So that's obviously just going to disappear, so that the remainder is the value of the polynomial when x is substituted for a. So the best way to actually see this, because it's quite abstract, is to actually look at an example. And here's my example. So find the remainder when this polynomial, which is x to the 4 plus 2x cubed minus x squared plus 6x, is divided by 2x plus 1. So I need to put in sort of the value of that. Now if you think about it when we're solving equations, quadratic equations, when we get down to our double brackets, we say therefore x equals the sign. So if I had x is, if something factorises into x plus 2, x minus 3, I would say my values of x are minus 2 and 3. And we do exactly the same here. So here, instead of 2x plus 1, I'm going to substitute in x minus a half. Okay, so you can see where the minus a half comes from that bracket. Substituting all the values, evaluate it through, and I end up with an answer of minus 3 over and 7/16. Okay, so that essentially is the remainder theorem.